Let's solve some circle problems. The first problems will be regarding the chord propositions. So question number 1. So we have to find this angle that is colored over here at B. So here we have 160 degree. So we can find the other side. So 360 degree is the complete revolution. So 360 minus 160 is 200 degree. Now angle at the center is twice the angle at the circumference. So this should be half the angle. So 200 divided by 2 is 100. So this angle is 100 degree. The next one, again we have to find this. So if this is 300, so by the complete revolution is 360, so this should be 360 minus 300, that is 60 degree. So at the circumference, the angle would be half of the angle at the center. So this is 30 degree. Next, we know that this is 210 degree. That means angle at the center, that angle is going to be half of that. 210 divided by 2 is 105. Now we have a quadrilateral over here. This is 60 degree, this is 105 degree. We can calculate this by subtracting from the complete revolution. 360 minus 210 is 150. And we can calculate this one by subtracting from 360, 150, 60 and 105. So let me bring out the calculator. So that would turn out to be 360 minus 60, that is 300, minus 150 minus 105, and that turns out to be 45 degrees. So this is 45 degree is question number 3. Now question number 4, you have to find this angle. Now we know this is 80 degree. So if this arc makes 80 degree at the center, then that means this entire thing at the circumference has to be half of that. Angle at the center is double, angle at the circumference is half. So this is going to be 40 degree. Now we already know that this is 30 degree and this is radius of a circle, this is radius of a circle, so it's an isosceles triangle. If this is 30 degree, this portion should also be 30 degree. Now we know that the entire angle here is 40 degree. So if this is 30 degree, then this angle should be 10 degree. Now if this angle is 10 degree, again this is radius. So the base angle, since it's an isosceles triangle, OB and ON radii of the circle, this angle should also be 10 degree. The next one, question number 5. Now we have, this is 140 degree. Now we know that if this is a straight line, then if you subtract from 180 degree, this should be 40 degree. Now next, we know angle at the circumference, then the angle at the center would be double of that. So this would be 80 degrees. So we found this angle at the center. And this angle is reflex angle. So if the entire thing is 360 degree, 360 degree minus 80 degree is 280 degrees. So this angle would be 280 degree. Let's move on to the next one. Question number 6. Now this is 70 degree. Now we know by straight angle rule, this is 180 minus 70, so this would be 110 degree. If this is 110 degree, you would be tempted to think this is cyclic quadrilateral, but it is not, because cyclic quadrilateral has to touch every 4 part of the quadrilateral has to touch the circumference. So this is the center. So anyway, if this is the angle at the circumference 110 degree, then on the other side would be double that angle. Double that angle is 220 degree. That proposition regarding angle at the center. So the next thing that we can think about, by the complete revolution, this entire thing is complete revolution 360 degree. So this would be 360 minus 210, and that would be 140 degree. Now the next one, question number 7. So we know that when we have an arc or a chord here, this angle at the circumference and this angle at the circumference will be same. So the angle that we have to find is this angle, but this angle and this angle are same. Now we also know there is a rule called vertically opposite angles. If this is 90 degree, this would be also be 90 degree because they're vertically opposite angles, they're equal. So now we have a triangle over here. So this is 90 degree, this is 30 degree. So this is going to be 180 minus 90 minus 30 is 60 degrees. So if this is 60 degree, Angle by the same chord at the circumference are equal. This is also 60 degree. Question number 8. Now what we have here is we have to find, it's not clear, is this an angle with this line BE and the arc? There can be an angle between arc and this. I guess this is, they have to find this angle. So let's see what we have to find. So if this is 110, then this is going to be 70 degree straight angle. So this is 70 degree. That means if this is 70 degree angle by the same chord BA or the same arc, this is 70 degree, this should also be 70 degree, because and like the circumference, they're all equal. Now then we have this straight line. So if this is 70 degree, this is going to be 180 minus 70 degree, and our angle is 110 degree. That's what we have to find over here. Now question number 9. In question number 9, what we have here is this angle. We have to find this angle, but we also know that by the same chord the angles are equal. So this angle and this angle, they should be equal. They're exactly the same. Okay, now this is what we know. We know this is 80 degree, we know this is 40 degree. So angle, sum of the angles in a triangle is 180 degree. So from 180 degree, if we subtract 80, we get 100. From 100, if we subtract 40, we get 60. So this is 60 degree by the sum of the angles of a triangle. That means by angle by the same arc. So they make the same angles. So this is also 60 degree. The next one, question number 10. In question number 10, we know this is the angle we have to find. Okay, so by the rule of same chord, so the same chord makes 44 degree over here. So it should also make 44 degree over here. So now this is a triangle. So if we take out our calculator, and from 180 degree, let's subtract 44 and 24. So subtract 44 and subtract 24, and we get 112 degrees. So this is 112 degree. These examples are with tangent. These are the tangent propositions. So this is 50 degree. So we know from a common point, when we have two tangents, they're equal. So isosceles triangle, the base angles must be equal. So 180 minus 50 is 130, divided by 2 is 65 degree, and this is also 65 degree. Now we know this is a tangent and this is a chord. Tangent and chord make the same angle that the chord makes at the circumference. So this should also be 65 degrees. So the angle that we have to find is 65 degree. The next one, we know that inside a cyclic quadrilateral, this should be together 180 degrees. So this is 70. 180 minus 70 is 110. Now it is given these two sides are equal. So the base angles should be equal. So the base angles are 180 minus 110 is 70, divided by 2 is 35. So this is 35, this is also 35. Now we have a tangent over here. So the proposition is the tangent and the chord, whatever angle it makes, is the same as the chord makes at the circumference. The chord makes 35 degree at the circumference. So this angle should also be 35 degree by the rule of alternate segment theorem. Now question number 3. So here we have, this is 60 degree. So by alternate segment theorem, the chord and the tangent makes the same angle that the chord makes at the circumference. This should also be 60 degree. So sum of the angles of a triangle says that 180 minus all these three angles should be 180 degree. So 180 minus 80 is 100. 100 minus 60 is 40. So this angle is 40. Then this should also be 40, because by alternate segment theorem, the angle between the tangent and the chord is the same as the angle that the chord makes at the circumference. This should be 40. Now this is a straight angle. If this part is 40, we should subtract from 180 degree. This should be 140. Let's move on to the next one. Question number 4. Now here we have to find this angle over here. The first information that we can see is that the radius and the tangent, they make 90 degrees. So this is 90 degree. The next information is given. This side and this side are equal. That means this angle and this angle, they should be equal. At the same time, this is radius and this is radius. That means whatever angle this is the same. So this and this is the same angle. That means if the base angles are equal and this angle and this angle is same, so this should also be the same. So this portion should also be 40. Okay, so the information that we have now, so this angle should be 40 plus this unknown. Let me call this unknown angle x. So by the alternate segment theorem, the tangent and the chord makes the same angle as the chord makes at the circumference. So this angle should be 40 plus x. Now we can do the straight angle rule. 40 plus x, let me write it out here. 40 plus x plus 40 plus this portion is 90 equals to 180 degree. That makes it x equals to 180 minus 90. 40 plus 40 is 80 minus 80, so that is 10 degrees. So this angle should be 10 degree. Question number 5. What we have to do here, we have to prove that AB is the diameter. If you have to prove AB is the diameter, we know that the diameter makes 90 degree at the circumference. So that's what we have to prove, that this angle is 90 degree. In other words, we have to find what this angle is. So find angle ATB. That's what we have to find ultimately, because if this angle is 90 degree, then it's the diameter. So let's find this out. Now the information that we have over here is that if this is 55 degree, then from the straight angle we can subtract it, and this would be 125. So this would be 125. Now this is a triangle, so we can find this. Sum of the angles of a triangle is 180 degree. So this together is 145. So 180 minus 45 is 35. So this angle should be 35. Okay. Now if this is a tangent, so by the alternate segment theorem, the tangent and the chord makes 35 degree. So this angle should also be 35 degree. Now let's take the sum of the angles of this triangle. We can calculate this. This angle is 180 degree minus 35 minus 55, and that is exactly 90 degree. So since this angle is 90 degree, AB is the diameter. The next one, we know that these two angles are equal. We have to prove that TBC is 90 degree. So TBC, we have to show that this angle is 90 degree. Okay, let's see what we know from here. The first thing that we can see is that we have a diameter over here. So COD is the diameter. So this is definitely 90 degree. This is definitely 90 degree. Then we have, this is a tangent. We have to do something about the tangent. So the tangent and the chord makes the same angle that the chord makes the circumference. So this angle should also be x. Now let's use the straight angle rule. So we can find this by subtracting everything from the straight line. So we can write this as 180 minus this together is 90 plus x. So 180 minus 90 plus x is 180 minus 90 is 90. Bracket open, this is 90 minus x. So this portion is 90 minus x. Let's take this triangle. So in triangle CBT, we can take this angle as x plus this angle is 90 minus x plus this angle is the unknown. So let me call it the angle, let me name it TBC, same name. So together it's 180 degrees. So now let's see whether angle TBC is 90 degree. So angle TBC equals to 180 minus 90. Now this x and this x cancels. So angle TBC is 90 degree. Question number 9, we have to find angle DAE. So angle DAE is this one, DAE. This is the angle that we have to find. Okay, so what we know from here, so we can see that the first thing that we have is this BOE, and BOE is a chord that passes through the center, so is the diameter. So this entire angle is 90 degree. So that means from 90 degree if we subtract the given angle 35, so 90 minus 35 is 55 degree. So angle DAE is 55 degree. The next one that we have to find is angle BED. Angle BED is this angle. This is pretty simple because we have a chord here BD. The chord makes the same angle at the circumference. So this is 35, angle BAD is 35. So then by the same chord, angle BED should also be 35, angle made by the same chord. Next we have to prove angle ACD is isosceles. So this is angle ACD, ACD. To prove that this is isosceles, we first have to find every single angle of this triangle, triangle ACD. We already know this is 35 degree. What else do we know? We just found this is 35 degree also. So in this triangle ADE, we can find this, sum of the angles of a triangle is 180 degree. So from 180 degree, if we subtract 55 degree minus this entire angle is 35 plus 20, also 55. So that would be 55, 55, 110. So this would be 70 degree. If this is 70 degree, from straight angle rule, 180 minus 70, this is 110. Okay, so we have this triangle right here. This is 35 and this is 110. So let's find the other angle, this angle. So from 180 degree, if we subtract 35 and 110, so 180 minus 110 is 70, 70 minus 35 is 35. So this is 35. So in this triangle, two angles are same, base angles are same. Therefore, it's an isosceles triangle. Now let's do this final example. We have to find angle DTA. So DTA, we have to find this angle. So let's see what information we have right now. Well, first of all, we have a tangent. And the tangent rule that comes to mind is alternate segment theorem. So the chord over here and this and the angle that the chord makes at the circumference should be equal. So this is 40. So we have this is 30 degrees. So we can find this angle, angles of a triangle. So 180 minus 30 minus 40 is 110. If this is 110, by straight angle rule, this is 180 minus 110, this is 70. Now this is also a chord and this is part of the tangent. So this angle and this angle should be equal by alternate segment theorem. So this angle should also be 70. So this is angle DTA. Next we have to find BCT. BCT. So BCT is 110 we have already found. So we don't have to find that. We already found that. Now we have to prove that BCT and BTD, they are similar. Now what does it mean to show that two triangles are similar? We have to show each and every angle, corresponding angles are equal. So let me draw this triangle BCT. So BCT is this triangle over here. BCT. So this is 30, this is 110 and this is 40. Now BTD. So BTD is over here. This is B, this is D, this is T. So this is 30. So we can say this angle and this angle is the same. Now we know this is 40, this angle D is 40. So we can say this angle and this angle is same. So when we have two angles same, then the third angle would also be the same. So thus it's a similar triangles. Let's do a few more sums. Here we have two tangents drawn from the same point. So that means it's an isosceles triangle. This and this is equal. Now we have this chord and this tangent. So the angle here is equal to this angles by alternate segment theorem. So this is 75 and this is also 75. So this angle should be angles of a triangle. So 180 minus 75 minus 75. So which is 150. So this should be 30 degree. The next that we have here is again the same thing. So we have this and this equal because tangents from the same point, they're equal, and the base angle should also be equal. This angle and this angle are the base angles. Now we know that this tangent and this chord makes this angle, and this is 105. So by alternate segment theorem, this is also 105. Also this is also 105. That means by straight angle, if we subtract 105, we can get as 75. So this is also 75. So now we have this triangle and we know the base angles are 75 and 75. So this angles of a triangle 180 minus 75, 75. So this is 30 degree. The next one, we have these two sides are equal. So the base angle should be equal. So this is 25 degree like this. Then we know AT and this tangent together, they make this angle 75 by alternate segment theorem. So this complete angle that we have to find is 75 by 25, and that should be together 100 degrees. The next one we have here is ET and AB tangent makes this angle by alternate segment theorem. So this is 50. Again, this is 60 by alternate segment theorem. This should also be 60. Together they make 110 degree. Let's do one more sum. So we have to find OTX. So OTX. So this is 90 degree because of radius and tangent makes 90 degree. So that's the rule. So this is 90 degree. Next, TOB. So TOB. Remember, TOB or TOX is the same angle. It doesn't matter. So it's the angle that we're talking about that matters. So this is angles of a triangle. If this is 90, this is 30, this should be 60. Next, we have to find, so this is 60. OBT, OBT. We know this is radii of the circle. OB and OT are the radii of the circle. So the base angles should be equal. So 180 minus 60 divided by 2. So this is 60 degree and this is also 60 degree. So this is 60 degree. Now ATY. ATY is this angle. So if you have to find this angle, then it means this angle is exactly equal to the angle at the circumference that the chord makes. But the chord does not make any angle at the circumference, but it makes an angle at the center. Now we know the angle that the chord makes at the center is always double. So that means whatever angle this is, this angle, it should be double of this angle. If this angle is x, this angle is twice x, because if by alternate segment theorem, this angle is the same as the angle at the circumference, and the angle at the center is double the angle of the circumference, then it means this angle should be double at the center. Same rule. So it means if this is 60 by straight angle, this will be 180 minus 60, so that should be equals to 120. If this is 120, half of that is 60. So this is 60 degree.